అయింది. Good afternoon, all. Good afternoon, Dr. Haral Wagner.
Good
We will
afternoon.
start 5-10 minutes.
Okay, no problem.
Thank you.
My pleasure.
Good afternoon.
Good afternoon.
How are you, Doctor? How are you? Good to see you
I'm
again.
fine. I'm fine. Thank you very much.
Yeah.
We are all kind of in isolation because right now, you know, I used to travel a lot, but now no traveling is possible.
Yeah. It's true for everyone now. All of us are, stuck
All
now.
of us, and we are all waiting for the next months to pass by and to bring the big change and go back to normal. Okay.
Now the hot news is that the vaccine is now.
The vaccine is what is called instato nascendi. You know, it is just giving birth to the vaccine, but it's not really now available already. But other changes are okay also, I think.
Yeah, that's right. Okay, is there anybody from the CBIP office here today? Mr. Dinkar there?
No, I only did hear Mr. Uttam.
Good afternoon, sir.
Is that
and
Kalpana?
Miss Kalpana.
Is that Kalpana?
I think I did hear the voice of Miss or Mr. Kalpana. I don't know. Is it Mr. Kalpana or Mrs. Kalpana?
Yeah, it's Kalpana, Professor, it's not Kalpana, it's in Indian Hindi language, it's Kalpana.
Kalpana, okay.
Yeah, you pronounce it correct. Now, is Kalpana there?
I'm not sure.
Why I'm asking? Because Sunil is not well.
Sorry.
Yeah.
I wish him well.
Yeah. He's on recovery path, but I think it's going to take a while before he comes on scene.
Okay. I only know that he was always on the CC, on the copy.
Yeah, so Professor, we will, I think, wait for a while because the number of audience is also small. I think there's just about 15 people, 16 people. I think maybe people are having some issue with the communication. We'll wait for another 5 minutes before we start.
No problem.
I hope you will not mind.
No problem. No, that's okay.
Okay. So, because I can't read everybody who's here, if there is anybody from the CBIP who's coordinating, please speak up. Please show up.
Yes, sir.
Yeah, please switch on your video. Let's see you.
Yeah, sir. The video is on.
Okay, video is on, but then how come we can't see you for the time being? Okay, you're going to. So is that Kalpana you? No.
The Kalpana madam is also there, and this is Uttam Rawat.
Okay, and who else is there from CBIP?
Sir, actually, Sunil sir and just a moment.
Okay, so in any case, we're going to wait for a while. We'll wait for a while till the number of audience increases, and then I will make a very short and brief introduction.
Thank you.
I can't see Mr. Dinkar. Is Dinkar Saab here today? No.
No, sir.
No, sir. He is also not available in the office today.
Okay, then Patel?
No, he is also infected with coronavirus.
I didn't know about Patel. Okay, I knew about Sunil ji, but I didn't know about Mr. Patel. How many total people have got infected now?
Yes, he also.
He and who else?
I guess Mr. Dinkar, now he is negative now. Mr. Dinkar is doing well. And
Dinkar also
Mr.
had
Patel got infected and Sunil sir. I guess these are the persons who got infected in CBIP. There is one more person, Mr. Bishop. Total 4, I guess, got infected with coronavirus in our organization.
Sad. Really sad, But in any case, I would message the others. In fact, I wrote something to Mr. Dinkar. He didn't reply, so I was guessing that kuch to problem hua hai.
Could be
I didn't know that
because
he's
of
also
yes.
See, this is unfortunate, but anyway. So if that be so, I think Dr. Wagner, we will not wait more now. So with your permission, yeah, shall I start? Others can keep joining as they are coming on.
Yes.
So what's your name? I was initially getting confused. I said it's Kalpana. So what's your name, please?
Kalpana, sir.
So you are Kalpana, no? So obviously, because what is coming written there is PC.
Because it's the IT system from which I have logged in. So that is the reason it's not written my name.
You've been writing and I've been replying to you, but we've never been face to face. So pardon my ignorance because I think I've never met you physically.
Yeah.
And so we haven't seen each other face to face. So I couldn't immediately.
We never
we never met in your office.
Yes.
So I was a very regular visitor, but for the last about 8 months now.
Hope to meet you soon, sir.
Corona. Yeah. Okay, so we will not spend any more time on introduction. Thank you, Kalpana. Thank you very much. And in fact, I will now request you to take stock of the proceedings for the day, Kalpana, if that is fine. Okay. So, whenever it's required to be coordinated, I will request you to do that. Okay. Good afternoon, all the attendees who are here. Once again, we are on a virtual meeting. and we are running again a training session by one of the very, very renowned speakers, Dr. Harald Wagner. Okay, ladies and gentlemen, before I come to introduce or reintroduce the speaker to you and the subject of the day, I think it is in the correct scheme of things. First, like always, bit a bit of caution that Corona is not gone yet. In fact, during winter time, it was expected that the number of infections will rise or go higher, and that's true. Not only in India, worldwide. Yeah, worldwide, the numbers are going up and likely to go up further for two reasons. One is the weather itself, and second reason is the festivities have more or less, people had removed the kind of precautions that they were taking. Large number of people interacted in large numbers, gatherings, which is not really required. And that's why we are seeing a larger number. So my request to everybody would be stay safe, stay away, and stay healthy. That's the only thing you have to, we have no other choice. But there's a silver lining always. You've been following news. Countries are now coming up with their own vaccines, lead taken by the US, somewhere in the UK, you heard of the various vaccines. I'm sure there is something happening in India also, but sooner than later, I think it is in our sight, maybe in a couple of months. The rest is everybody's guess. So no more on Corona. Let's start on a positive note. A word about our Tunneling Association of India. We all know that it's actually an integral part of our CBIP. It joined the International Tunneling Association, ITA, in the year 1976. And as on today, we have more than 600 members. Primarily, we deal with the tunnels and the underground space. As far as the TI in India is concerned, it's a single platform for sharing information, for exchanging information, for sharing of ideas, for training sessions, we do publish publications also, run certain workshops like this, the way we are organizing today, and we are the official link of the country with the ITA. The official representative of India to represent the country at the ITA as a forum is with the TAI. We host the WTC as and when the chance is given to us. In addition to that, once every 2 years, we organize Tunneling Asia. And also along with that, on the sidelines, we conduct the Tunneling Awards. We are very, very concerned about the safety aspects. And that's why a large number of deliberations have happened in the recent past about the tunnel safety. And like we mentioned, one good thing which has happened is about 2 years back, we have added a new chapter called the Young Tunnels, Young Members, young members, those who are young than 35 years and are in this profession. Now, for some time now, we have our sister organization called the Center for Excellence for Tunnels from the National Highway Infrastructure Development Corporation Limited, which has also got a similar kind of a mandate, but they are our younger brother. They are still in a fledgling state, and they are most welcome to be with us so that we can work together. But essentially, they work toward the thought leadership, strategic advice, and the problem-solving inputs. So the two together can work in a very collaborative manner to further strengthen this industry and this particular segment of the academia, that is the tunneling. Okay, now coming back to the speaker of the day, ladies and gentlemen, Dr. Harald Wagner needs no introduction. I think by now all of you know him. Still, let me read a little bit about him. I can take 1 hour to introduce him, but I'm going to take 3 minutes. I hope the professor is not going to mind it. Now, he's a civil engineer by profession. He's done his master's, he's done his PhD, and he is a government counselor appointed by the president of Austria. He's a chartered expert at the courts. He's a consultant to the World Bank. He's an international well-recognized consultant for the underground infrastructure with more than 40 years of professional experience, I think more than anybody else present here. He's also been, like I said, I always address him As a professor, he's also been an assistant professor at the Technical University of Graz in Austria. And those who know about it, I think it's a dream come true if you ever land up in this university to study the science of tunneling. Okay, he has been a very active member of the ITA fraternity, including as the vice president. He's an expert member of the executive council. And like I said, that I can keep explaining that you name a thing, he's done it. He's got experience on ground. He's been teaching, he's been researching, and he's been coordinating. And now, like he's saying that this is his passion, that the knowledge that and the experience that he has gained over a period of time, he likes to share it up. Okay. About the program for the day. Now, the subject for the day, you have all understood, is the tunnel and underground space. The scenarios in design. Okay, now you almost understand that why do we go underground? Where is the need to go underground? 2 or 3 major reasons. One is that we are getting choked over ground. So we have no option but to go into the underground space. 2, there are certain requirements, peculiar technical requirements, like the hydro tunnel. Now, hydro tunnels can't be made over ground, although there are examples they've been made over ground also. But essentially, caverns is another thing, which is nothing but an underground storage. Okay, so he's going to be talking to us on the tunnels and the underground caverns also. Caverns is nothing but a structure which is either dig into a hill face or underground space. In fact, I was discussing with some of my colleagues who are designing something, an expressway in Mumbai, and Mumbai is infested with water problem. And I recommended to them that, look, surface drainage will get choked after a point of time. Your pumping systems will fail. Where will you throw this water? One fine day, we will have no option but to go underground and make an underground, whatever you call it, a water holding tunnel or water releasing tunnel or simply a drainage tunnel. These are the evolving solutions. Metro is another feature which has caught the eye of the world today, that come what may, we are now resorting to underground structures. Now, each underground structure has got a payoff, but it has got a peculiarity in the design also. It is not one size fit all. There are a number of ways of looking at it, but then there are reasons for doing the optimization of the designs also. So I'm not going to speak more about the subject. I think we got expert to speak about that. I was just trying to introduce that subject. So with that brief introduction of the subject and a very brief introduction of our speaker of the day, over to you, Professor. And I'm very sure we are delighted to have you with us. And me and all my colleagues sitting here listening to you, at the end of the day, I'm sure we are going to be enlightened with your deliberations of the day. And like always, I know that you're going to keep it very simple for people who are not very, I would say, very experienced designers, also to understand as to what are the nuances. So over to you, sir, for the day's proceeding.
Thank you very much for your very comprehensive introduction. From the point of view of the picture on the screen right now, maybe you can eliminate the one line which indicates the telephone participants, hand raise, and mute the microphone and so on, so that I have only this picture. Anyway, I would like to start with a very brief retrospective of what the lecture series so far have been. The first lecture was provided in August on tunneling technology in design and construction. And then the second virtual lecture was provided in September on tunnel construction concepts for conventional tunneling and for tunnel boring machine or mechanized tunneling. The third one was in October, a virtual lecture on tunnel maintenance and repair. And this one in November, on today, on the 25th of November, is the lecture on tunnel and underground caverns with an undertitle, which I call Scenarios in Design. Now, these are the 4 lectures until now, and the future lectures will be the geotechnical characterization and ground investigations. This will be the 5th lecture. The 6th lecture will be, the 5th lecture is in December, and in January, again, a lecture on tunnel cavern design and layout, which I would suggest to make a modification, because 2 times talking about caverns and tunnels maybe is not covering everything. So the 6th lecture maybe will be a ground investigation. And the 7th lecture will be then on conventional tunneling, or NATM tunneling, and tunnel boring machine design guidelines. The lecture in March then will be on contract models and risk assessment. And the last lecture in April on life cycle assessment of tunneling works. So that's about the overview of all the 9 lectures, and the 9 lectures will be provided at the end of the 9th lecture as a compendium to the participants to have all the lectures and all the pictures in the lectures in the form of slides and PowerPoint presentations will be provided in a compendium. Okay. If we go to the next slide, I think we can just have a brief introduction. Can you go to the next slide? Mr. Utan, you proposed to make the slide presentations upon my request. So this is the slide which we have already talked about. My bio sketch, which I call bio sketch, and there's only a very little difference between the other presentations on the before mentioned virtual lectures, because I am also an ITA surveyor, and that has not been mentioned on the slides at the previous virtual presentations. So the ITA surveyors is responsible for surveying on an annual basis the ITA-set, the so-called ITA Committee on Education and Training, annual balance sheets, and has to give a report, a short report in the range of 10 pages to the International Tunneling Association. As a surveyor, I have to do this annual report also. So we can go to the next slide. And the next slide is the lecture outline. After the introduction, I will give, because I call this lecture today also Scenarios in Design. So it's not only tunnels, shafts, and caverns. It's also different scenarios in underground structures. So that will be, after the brief introduction, deliberation on global population development, then on different types of classifications of tunnels, and also of soil and ground classifications. Then there will be a brief deliberation also on support systems, both for conventional tunneling and for mechanized tunneling. And then chapter number 5 will be on the summary of the advantages which underground structures, tunnels and caverns are providing. Then what about the structure demand which we have in the future? And this will also correspond to the mentioned scenarios before, the future of infrastructure, and also some elaboration on environment. And one of the cores of this virtual presentation today, design phases. And then on design work progress, on observation and monitoring, and also on some constraints, and finally final lining and summary. So we can go to the next slide. Okay, so can you please just delete what I have in the picture now? I have a line, as I mentioned before, if it's possible to delete that. If you look to the slides, if not, it's okay also. Okay, in the introduction, I'm talking about why underground tunnels and caverns are becoming more attractive, more economic, and more safe in the future. Then I will talk about the fact that even odd surface areas are receiving increased attraction from developers. So why are they receiving increased attraction? Because above ground structures are disturbing the surface life, are disturbing the sceneries. Surface space will rise in value, mainly due to mentioned achievements of underground technology application. Underground tunnel and cavern design shall always include the initial site investigation because we don't know what is underground, so we have to make site investigations. We have to also look into possibilities for dewatering. We have to look into ground improvement adaptabilities, and also in other auxiliary measures which are related to underground cavern design and tunnels. So the adaptability of support include how adaptable is shotcrete thickness, how adaptable is the use of welded wire fabric, so how adaptable are lattice girders to different ground conditions, and how adaptable are spiles and anchors as pre-running support, and the like. The next slide, please. The next slide will show you all of the different types of technologies which we apply in one picture, which is, can you go to the next slide? Yes, the next slide shows before we go to that. Maybe we can go back one slide. Yes. Now on this slide, you can see in the center part, you can see the assembly of a tunnel boring machine and all of the pressures and valves which are quite complicated in that machine. You can see also the cutting wheel, and you can see lowering down into the shaft the cutting wheel. You can see conventional tunneling on. I can show you with this the conventional tunneling picture here, and that's a very large picture. That's the connection between a very large tunnel and the shaft outside, and then you can see here also boomers and all type of other shaft equipment in soil and in rock. Okay, next slide, please. What is on the scenario on the surface really is a disaster. And this picture shows you this type of disaster from Shanghai with all the skyscrapers which are all above ground and disturbing the environment. So it's a real disaster. On the right side, you can see a picture from Los Angeles, from a major complex interchange of highways. Los Angeles and California is a super developed and super tense infrastructure of transport of roads. So that is really only we can say it's a disaster on the surface. If we go to the next slide, in the next slide we can see a brief overview of the global population, which the expectation is that there will be 10 billion, the population will be 10 billion people in 2050, with the median average between these exaggerations. In fact, it means that it is going to be tripled in less than 90 years. We have predictions with 80% and 95% prediction interval, and we have also the actually observed line here. Okay, so this is the global population, and we can go to the next slide. And the next slide shows something which is related to the global population. That, for instance, in 2015, we had 1 billion vehicles which in operation globally, 1 billion, which is expected in 2050, means in 30 years from now, that we will have 2 billion vehicles on our planet. And all these vehicles, they have, of course, a heavy impact on global warming, on climate change, and also on the behavior. So this means that the change, in my opinion, will not be very big if we have until 2050 a higher percentage of electric vehicles, but we will still have the problem of the transportation in that time. Okay, so the next slide, please. On the next slide, we can again see a summary of the development with regard to urban and rural increase of world population. We will have, as we have had in 1975, so 45 years ago, we had 3 million megacities on our planet. In 2011, we had already 21 megacities on our planet, and by 2045, we will have a population in regard to megacities. The megacities will host 70% of the population in 2045. At the same time, we also have an increase of the average age. From 1960, where we had an average age worldwide, we had 53 years average, and in 2010, we had an increase of almost 25% from 53 to 69 average age of the world population. At the same time, if we look at energy consumption, we have to say that at that time we have had energy consumption of 5% of the population, which has consumed 23% of the energy, and we have had 13% of non-potable water at that time for that 5% of population, and 38% of the population at that time had no access to sanitation. So in 2008, it was the first time in the history that more people have been living in cities than in rural areas. So we definitely have a strong shift from the rural area population to the city population with all respective problems. Next slide, please, slide number 10. Slide number 10 is an introduction into the classification of tunnels, in particular from 3 points of view. One point of view is what is the service of the tunnel, and from that point of view we have road tunnels and railway tunnels and metro tunnels, conveyance tunnels and drainage tunnels, and caverns. From the point of view of service, from the point of view of location of tunnels, we have tunnels in water, we have tunnels in mountainous tunnels, and we have mountainous tunnels also. We have shallow and deep tunnels. From the point of view of geology, we have tunnels in rocks, we have tunnels in soils, and we have tunnels with mixed phase, and I will deliberate a little bit more in the next slides on that mixed phase conditions. So can we go back to the other slide? The rock classification. Yes. From the point of view of rock classification, we have different types of classification systems. And there is the classification system from the point of view of the rock loads. And Terzaghi has done a classification of rocks with that regard from the point of view of stratified, of intact rock, of squeezing rock, of crushed and so on. So this is from the point of view of rock loads, the classification of Terzaghi, which is almost 100 years ago now. From the point of view of rock quality, and I would kindly ask you to look into these tables when you get the soft conditions. Yeah, from the point of view of rock quality designation, so-called RQD values, the RQD values which have developed by Professor Deere from the United States, and which is to calculate the RQD, makes the difference between excellent rock, between good and fair and poor and very poor rock conditions. So for instance, excellent rock has an RQD value between 90 and 100, and good rock between 75 and 90. And the fair rock has a qualification RQD value between 50 and 75, and the poor rock between 25 and 50, and very poor is lower than 25 RQD value. So another rock classification is from Wickham, the so-called rock structure value or RSD. In that regard, again, there is a classification with regard to constructive parameters, direction of drive, size of the tunnel, and so there are different parameters which give an indication of this classification. Then a very common classification is the rock mass rating classification, or RMR, according to Bieniawski. And Bieniawski has used different parameters for evaluating the range. And the range is evaluated, for instance, for uniaxial compressive strength between 0 and 15 for rock quality designation, between 0 and 20. So this is depending on the experience of the rock engineer, of the specialist for rock engineering. Then another one is the spacing. Another one is the combination. And another one is the groundwater condition, and another one. So there are different parameters according to Bieniawski. But there are also the rock mass quality according to Barton. And again, you can look into these tables and make your own classification of the RMD classification. So actually, we can go to the next slide, please. If you can delete on the picture, I don't need to see the show participants and so on. Can you delete this? And bring the next slide, slide number 12. Slide number 12 shows one of these excavation in progress. Excavation in progress, it shows a road header. It's a so-called Alpine Miner 100 road header, which is in particular a very smooth excavation. But it also shows you that from that point of view, you have an open face and you can make your rock classification according to whatever the classification you have decided to use. So the next slide, please. Slide number 13. Slide number 13, yes. Yeah, can you delete the line in the middle of the slide? Just show only the slide on slide number 13 and on the other ones also. If you cannot, it's okay also. Okay, this slide shows an example of mixed phase excavation between sand and hard clay in the upper left corner of the slide. And on the right side, you can see the TBM, which just enters a shear zone. And you can see that this shear zone is also considered to be a mixed condition. On the lower part, you can see the mixed conditions or changing ground conditions between sand and boulders. And on the right side, you can see also that we have an excavation with a tunnel boring machine where the groundwater is above the machine. So the machine actually has hydropower pressure from the face. Can you once again please try to clean No. To clean the line in the middle of the slide. I have a slide which prevents to show the full slide. Can you delete that line here? This in the middle.
So it's a PDF version, so we cannot edit right now.
No, you know, this is not originally on the slide, you know. The slide.
We are not seeing any line in between. This may be something at your end. It is pretty clear to us.
It's maybe only on my slide on my screen, but it before you had already deleted it, so maybe you can try again. Otherwise, we go to the next slide, to slide number 14. Yes, slide number 14 is a slide which explains the design in rock according to the International Tunneling Association. And this slide also shows what we have. It follows a suggestion from Professor Dudek from the University of Braunschweig in Germany. It starts with the site investigation. So the point of view of geology is covered. Then it goes from the geology to the geotechnical investigation and the determination of the ground characteristics. Then the next step is the information which we get from previous experiences with regard to the choice of the excavation method and the structural elements. Then we go from there to the mechanical model with the statistical system analysis, structural system analysis, and from there we go to the consideration of what kind of safety concept and failure hypothesis we have to look and what design criteria have to be applied. Then from here we have to decide either we go, if yes, to the contractual aspects, or with no, we have to start again to consider excavation method and structural elements and go through the same again. Okay, then from there on, please take a look. I have to turn on the light because it's getting dark. We have to take a look through. It would be really better if you could delete this line in the middle. Cannot. Okay, now it's okay. So the risk assessment is the next step. We have to look into contractual aspects from the point of view of risk assessment. Then actually we start with the excavation and driving the tunnel. And when we drive the tunnel, also we go to field measurements and in situ monitoring of deformations. So then we have to decide if yes, that we are on the safe side, or if no, then we have to go again to determine ground characteristics. Now it's again, please can't delete again. Now it has been clear, the picture. Can you try again to delete that? Hello? Can you try again? Maybe you go to the next slide, slide number 15. Yes, but can you delete the line in the middle?
Hello.
Yes, you did it already, but now it's again. Can you just delete the slide, the line in the middle of my slide?
Could you just do one thing, sir?
Yes.
Three dots in Three dots are
The
there
image
in
is
the
quite clear in our system. There is no line in between.
I'm not actually not really happy with that that I cannot read the slide on my screen. Okay. Slide number 15 is a summary of support systems. You know, all of the support systems which you have in tunnels. It starts with steel arches. This is the ancient method. Terzaghi has mostly used steel arches for his support of tunnels. Then we go over to the next, which are anchors, anchors with plate or with expansion anchors, with steel bars or other reinforcement or steel cables or fibers. Fiber anchors are also specifically then used when we have to make pre-support and then excavate the pre-support. Okay, the next support is shotcrete. The most common support is shotcrete, where we use either dry shotcrete and shotcrete with fibers, or shotcrete with steel fibers, or shotcrete also sometimes with plastic fibers in it. Shotcrete with plastic fibers is very useful, in particular when we are in areas where we have to provide high fire resistance of concrete in the tunnel. Hello. Oh yeah. Does not disappear. Okay. Then we go to concrete segments. Concrete segments nowadays, it became standard to have either without or with expansion of concrete segments, and with connectors or without connectors between the segments. And then we have final linings of cast in place concrete, which could be either plain concrete or could be fiber reinforced concrete also. And then we have concrete as a final support system, also concrete or steel segments in use. Steel segments have been used last time, to the best of my knowledge, was a metro in Hanover in northern Germany, but that was the last one. And before that, steel segments have been used in United Kingdom, as far as I know, and in the United States also. But nowadays, almost steel segments are completely out of use in underground structure. Can we go to the next slide, number 16? Okay, this slide shows basically how a shotcrete shell is built up. Okay, we have the primary shotcrete support. Sometimes on the primary shotcrete support we have also welded wire fabric, and then we have a plain smoothening shotcrete. On top of that, welded wire fabric. And then we have a waterproofing membrane. And the waterproofing membrane sometimes is applied on a geotextile fleece. Okay, and then we have the final lining, the final concrete lining. So this is the members of or elements of a lining with the shotcrete system. And on the right side, you can see the picture, the application of the shotcrete in a real, and the size of this tunnel indicates that it is a transportation tunnel, most likely a highway tunnel. Okay. Next slide, please. Okay, the next slide is again dealing with support design, and you can see here it starts with the engineering process, and then from there on we go to the hazard identification, and from the hazard identification we develop the conceptual design, and from the conceptual design we go further to the detailed design, and from the hazard identification we go further to the risk assessment. So I would really appreciate if you could once again try to delete this line, which is covering part of my slide on my screen. Can you please try again? It's really disturbing.
Sir, could you do one thing, sir?
Yes.
Yeah, you just not move your cursor from your laptop, because when you move cursor from on your laptop, then this screen is visible.
It is covering the screen on my laptop, you know. This
Yes,
is,
sir.
but I cannot do anything. I think you have to do it.
No. From our side, sir, it's quite clear, sir. From our side, no problem, sir.
It's only on my side.
Yes, sir.
So what can I do?
Hello.
Yes.
Hello. Yeah, I think Mr. Herald required to get full screen of that PPT.
Right. I don't have full screen.
Yeah.
Sir, on your screen there is 3 dots, sir.
Yes.
Yeah, you can just click on this.
I have 3 dots, and there is enter full screen. Okay.
Yes, sir. Yes, sir. Yeah, you can just click on full screen, sir.
Yeah, but it's still covered. It's not. It is full screen, but there is a line which is covering my slide on my screen.
Hello.
So,
hello. I think the person who is having the control of PPT, he can try once to get the full screen.
Yes, I definitely would need the full screen.
Ravinder, raise Uttam, ask Uttam to help.
no, from our side it's full screen, sir. Everybody is
No, but we are unable to read at least what is his mentioning on that slide also. It's very small.
Yeah, it's
The
PDF actually,
content
sir.
size
That's
is
why.
quite small.
I have one participant also, JB Chethaver Pavesh.
Yes.
Is also covering my slide.
Okay, I guess participants are coming in between or over the presentation of Mr. Harald's screen.
I cannot. I cannot delete that. I don't know what the problem is. Really funny. Okay. Anyway, the slide is here, and you will get it. Everybody who is in the lecture today, everybody will get the same slide. So it will be full slide. Okay, let's go to the next slide. Next slide will be slide number 18, support. I cannot see the slide. That's really. Okay, anyway, there are different methods for the design. There's the empirical method, then there is the analytical method, and then there are numerical methods. And you can see here also the type of mined or tunnel boring machine, excavation, the empirical method, Art Deco is quite famous, developed by Lunardi, is based on numerical analysis, two-dimensional, has no specific time effects. Then the closed form analytical method has been developed by Muir-Wood and Curtis and Einstein and Schwarz and Dudek, Erdmann, and there was also one example or one source, international tunneling, recommended by International Tunneling Association, the so-called embedded beam spring method, which is an elastic material method, and the stability analysis according to Meyer and Taylor, and so on. And then there are the numerical methods, but I cannot talk about that because it's covered on my screen. I cannot see it. Okay, let's go to the next slide. Hello. Okay, so the next slide is the slide for the design of fractured rock. And from the point of view of fractured rock, we have, again, the method mentioned before, empirical methods, analytical methods, and numerical methods. So in the design, we always have to make a decision for what kind of method we are looking for, specific conditions of a tunnel. In the empirical methods, we do have here mentioned Bieniawski and Barton and Palmström, and can be used for any tunnel shape and any excavation method as far as this mined method. The analytical method, according to Barrett and McCreath, is a stability analysis, which is looking into the material as a plastic material. And then we have the numerical methods according to UDEC, or two-dimensional or three-dimensional, and different types of elastic and plastic behavior. So still, I cannot see the full picture because it's covered on my screen. Let's go to the next slide. Hello. Yes. Now the next slide is slide number 20. Slide number 20, and I'd like to give you one of the spectacular examples of a project where we have tunnels and shaft and cavern design, and that is the CERN project in Geneva, which is providing the effective expansion of urban space through this project, where we have a number of shafts, where we have different types of galleries and tunnels and cable trajectories and computer control caverns and so on. It's an improvement in intensification of land utilization, effective alleviation of traffic pressure, winning an ecosystem city via energy saving, and also improvement of disaster prevention capability. We can go to the next slide, please. Next slide. Now now for a moment I had a clear slide, and now it's covered again. So can you check how you did just now? You did uncover this covering line on my slide. Can you try it again, please?
Wagner sir, I have one suggestion actually. Wagner sir, can you listen?
It's a little bit of frustrating, you know, if you cannot see.
Wagner sir, are you listening me, sir?
You just did uncover, and now it's covered again. You uncovered for a moment.
Sir, what my suggestion? If you are having your own PPT, you can see from your own PPT, sir.
I don't know what to.
No. You open your own this thing. Let it be this one also, because it is only audio you share with us, and then this this PPT you can see your own.
No, I cannot. I cannot because I think it's on your panel. It's not on mine. Anyway, we have to continue. We have to continue explaining what CERN is. CERN is the European Organization for Nuclear Research. And the main function is to provide underground infrastructure with tunnels, shafts, and caverns as particle accelerators needed for high energy physics research. So that is really a fascinating application of our science. In CERN, there have been numerous experiments being constructed through international collaboration, and the main site host is a large computing facility with primarily used to store and analyze data from these type of tests of experiments. Interesting enough, also CERN is the birthplace of the World Wide Web, WWW, and with that of the internet. Okay, let's go to the next slide, please. Yes, the next slide shows you the existing LHD, which is the Large Hadron Collider, and the one which is in work in progress, is the Future Circular Collider. And the Future Circular Collider is an underground tunnel system of 100 kilometers. 100 kilometers to make the most interesting physics in terms of quantum mechanics and the tests, to find out about what holds together the inner energy. So that is a fascinating application of tunnel shafts and caverns. Next slide, please. Yes, we have a huge demand of underground space for the future. And this relates to research physics, like CERN. This relates to all transit systems, motorways, highways, public utilities, flood control. It also relates to revitalization programs of city centers and also all types of public buildings. Okay, next slide, please. Next slide. Yes, next slide is another project which is in discussion right now here in Thailand. Let's say in Southeast Asia, which is a mega flood control project with more than 1,000 kilometers of tunnels on different, combining different rivers, the Mekong River and the Lower Ai River, the Chi River and the Moon River. And there are a total of 17 tunnels, and on one branch, and another branch has a total of 7 tunnels, which are located in the northeastern region of Thailand. If we go to the next slide, I can explain a little bit more how nature has created deserts, but now humans and infrastructure is creating second-hand natures. With next slide. Which is another mega project, yes. So on this slide, you can see here the mouth of the Lower Ai River with 200 meters above sea level. And then you see all of the channels and the tunnels in the northeastern corner of Thailand here. You can see these tunnels, and all of these tunnels go to the Mekong River, which I cannot see here because it's again covered. But on your slide, you may be able to see that always the flow of the water, of the diversion of the water is always, it goes from higher to lower level. So we do provide kind of support of the nature by providing this connection from the mouth of the Lower Ai River down to the Mekong River. Okay, so that's another fascinating project which is in discussion. And also you can see here in color the different height of the topography where we have more than 215 meters, which is the brown area, and then between 195 and 215 meters, which is the green area here, and the blue area and the yellow area, which is lower than 130 meters. So the flow of the river always from the higher to the lower area, and providing in this area the future for agricultural use and for the population. Next slide, please. Yes, another fantastic scenario for future in infrastructure is Masdar in Abu Dhabi, which is a city with zero emission and zero garbage. Transportation and utilities are a major focus of the design. And you can see here the kind of axonometric or X-ray view of the city with building plots and street level, but also you can see that how the need for underground railway stations, roads, water, sewage, gas, and electricity is provided here. Basically, why? Because underground infrastructure has no limits. Underground infrastructure also has a huge potential for further development of power plants, nuclear power plants, of toxic waste facilities, but also of subsea infrastructure. So there is really a fascinating scenario for the future application of underground infrastructure. Next slide, please. Yes, what is the future of cities? Now, the World Economic Forum, WEF, has had one chief representative, was Mr. Björkman, and he, in his vision, the cities are the future of this planet, are becoming the future of our planet. In 2020, more people live in cities than in rural areas. We have mentioned that before already. And in 2050, in 30 years from now, the world cities will absorb 3 billion people. 70% of the population will live in urban areas. And this represents the biggest shift in civilization. The biggest shift in civilization and some cities, even with more than 10 million people population, are called mega cities. So by 2050, we will have about 45 mega cities on our planet. So this is the future of our cities, the future scenario. Next slide. Now it disappears. Okay, now I have the first time a full picture. Okay, very happy. How did you manage that? Thank you. Now it's back again. Why is it back again? I don't know. Can you manage again? Yes. Okay. You did blend out my picture. No need to look at my picture. Okay. The picture shows the inauguration cabin of a future train tunnel, which has been designed with the guidelines following the safety requirements during construction and during operation, following the guidelines for the safe environment, and also following aspects of cost control. So the next slide, please. I'm very happy because the slide is clean now. Okay, so this slide number 29 shows all of the concerns which we have when we look into a tunnel and into an environment around the tunnel. The concerns are related to ground reactions, to risk scenarios, to the existence of nearby structures, buildings, types of structures, walkways, utilities, buildings, to the influences from displacement and the field of such displacement, and the sensitivity to potential damages. Now, what shows this picture, and the red circle in the middle of the slide, it shows a collapse of a building because of underground construction in Cologne in Germany. That was about 10 years ago, that they have done some excavation under these buildings, and then the knowledge about, in particular, the sand silt conditions in this specific case underground have been underestimated also from the point of view of diaphragm walls as retention structures. So it all collapsed. And this shows what kind of urban environment we are sometimes facing risks and problems. For the next slide, please. Slide number 30. I want to give you a very brief and very simple overview of available tunneling technologies, both for shallow and deep tunneling and for soft ground tunneling. And we have conventional tunneling, also NATM tunneling, called with or without ground improvement. We have mechanized tunneling, all covering these shallow and soft and mechanized tunneling with full phase excavation. And we have some special methods also from the point of view of trench methods. So all this is an overview, a simplified overview of available tunneling technology. Next slide, please. So we go to the one of the core presentations of this lecture today regarding tunnel and cavern design phases. A tunnel project, usually if you follow these ITA recommendations for the project design, the design is composed of following stages. There is the conceptual design as stage number 1, the preliminary design, stage number 2, the tender design, also called the detailed design phase 1, number 3, and number 4, the construction design or detailed design phase 2, and the geotechnical design. And I will give you also recommendations how these different phases, what they should, in the different design stages, what they should provide. Next slide. Next slide shows you the principles of the conceptual design. The conceptual design has to include the scope and the verification design. It has also to include a selection of the preferred alignment from an alignment study, from several alignment studies even. The geological and hydrological information has to be collected to develop the geotechnical characteristics in the conceptual design. And the validation of anticipated tunnel construction, including environmental aspects, very important. The validation of the anticipated tunnel construction, also based on previous experiences of comparable projects. The conceptual design also has to include a cost estimate and has very essential to include the construction schedule in the concept design. And if there is a transportation tunnel, also the conceptual ventilation scheme. Of course, there is no ventilation scheme in hydropower tunnels. Next slide, please. In the preliminary design, what is the target? The target is to receive the approval from the client. So we are already behind the conceptual design, and now we are seeking the approval from the client. The preliminary design has also to include the evaluation of site investigation and from laboratory test results. So we have to evaluate whatever this is, and this in further, and it has been mentioned in the lectures before, results also in the geotechnical baseline report. It has to identify the portal locations and the portal structures. If there is a transportation tunnel, we always have in the portal structure, we have some sort of control building. Then it has to develop the typical cross-section. The typical cross-section for whatever use of the tunnel it is has to be part of the preliminary design. Then the waterproofing, if there is waterproofing, and drainage concepts, both during construction and also in operation. Construction concept should also include water and power supply concept, the location of construction roads, the location of muck deposits, and all that has to be included also in the preliminary design, as well as the detailed construction program already. So we have to understand what the different phases of the construction will require in terms of time and also in terms of cost. It has to include in the preliminary design a revised cost estimate. So this revised cost estimate is the one which mostly goes already to the public authorities, and from there, therefore it is a very sensitive issue to have a good construction concept, because otherwise it may be looked at as source for corruption. Okay, the next slide, please. Next slide is the after the preliminary design, the tender design. The scope of the tender design is to detail the works in such a way that a more exact pricing of each work item becomes feasible. So the tender design includes what? It includes the detailed design of all structures and incorporates the latest project development. It results in additional site investigations, if they are necessary, and requirements, any requirements by the client, by the authority, by the owner of the project. It also has to update the geotechnical progress, the geotechnical prognosis, the prospect of the geotechnical conditions, the support measures, the drawings, the distribution of the support classes, of the rock classes, what kind of rock engineering we are doing, the detailing of auxiliary construction methods, means ground improvement, dewatering, and so on, and the provision of information as required by the national standards and guidelines. And that is something which is very different between different countries. So we have to correspond with the national standards and guidelines. The next slide, please. Okay, slide number 35 is the construction or final design. The scope of the construction design is the detailing of the work described in the tender design stage in such a way that they can be constructed. Yes, we also have to do something which we can construct, and we cannot do something which is not feasible. However, what is including in the construction design? It includes the adaptation of the detailed design to the particular requirements of the excavation and support methods selected for construction, and to the geological and geotechnical conditions encountered in situ on the construction site, as a particular aim of conventional tunneling contract conditions found on site. Conventional including mechanized tunneling contracts also. This final design has to produce the design drawings which are used in construction. For example, the formwork drawings, the reinforcement drawings, the schedules, the fabrication drawings, and so on. So all this is in the construction or final design to be included. The next slide, please. Next slide is the geotechnical design in design. We have a geotechnical design in design, and we have a geotechnical design in construction, which is an accommodation of the design in construction. So the design has to contain the baseline construction plan. This baseline construction plan describes the expected rock mass conditions, the assumptions, and the boundary conditions the design on which the design has been based on. The plan also has to contain a clear statement describing which measures cannot be modified during construction, as well as the criteria for possible modifications and adjustments during construction. So this relates heavily to the flexibility of the contract model. And as I told you that in one of the future virtual lectures, we will talk about contract model. So this is a major issue of what criteria we have for the possible modifications and adjustments. That means, just to give you an example, if we have a class 5 design for a road tunnel, and in the class 5 design, we have the distribution of the rock anchors in the design, and then in fact we are running into the real conditions on site, and we see that the deformations are exceeding the ones which we have expected. Then we have to modify. So these modification criteria and adjustments have to be defined in the geotechnical design in design. So the results of all phases of the geotechnical design have to be summarized in the geotechnical report, or also called the geotechnical baseline report. Okay, the next slide, please. Next slide. Next slide is slide number 37, which is geotechnical design in construction. So in construction, excavation and support measures have to be decided based on criteria laid out in the baseline construction plan and the safety management plan. So this is an update of the geotechnical design in design, is the geotechnical design in construction. The geotechnical design and the baseline construction plan, they have to be continuously updated based on actual conditions and findings on the construction site. The geotechnical relevant rock mass parameters have to be collected, have to be recorded, have to be evaluated in order to determine the rock mass type. So the rock mass type and also the geotechnical baseline report have to be adjusted according to the actual conditions in construction. And the monitoring data together with the rock mass type will allow the rock mass behavior type to be determined. So I would like to come back also to that difference between rock mass type and rock mass behavior type. So the rock mass behavior type is following the performance of the contractor during construction, while the rock mass type is defined in the geotechnical baseline report and is the responsibility of the authority or of the owner of the project. So the rock mass behavior is determined by the construction company. Next slide. Slide number 38. Okay, this I call the design work progress. So the work progress is defined by the initial site investigations, by the dewatering measures, which need to be adoptable, means that I have to adjust the dewatering measures to the actual conditions of the groundwater during construction, to the adaptability also of the ground improvement. The ground improvement needs a special, I would call it a sub-project, where we adjust ground improvement measures according to the conditions which we are faced on site, and other possible auxiliary measures. Also, work in progress is the adaptability of the ground support. For instance, the shotcrete thickness, for instance, the arrangement of lattice girders, distance between the lattice girders, type of lattice girders, weight of lattice girders, structure of lattice girders, and so on. And also on the type of spiles and anchors. This picture on the right side shows one of the Singapore underground caverns for the storage of crude oil, which is a very important project. It's also a mega project in our neighborhood in Singapore. Next slide, please. The importance of observation and monitoring. So what do we monitor? We monitor settlements. We are monitoring buildings. We are monitoring deformations. We are monitoring by the use of sliding micrometers or inclinometers or other types of instruments. We are monitoring lining deflections. We are monitoring stresses in the lining. We are monitoring pressure cells, and we are monitoring groundwater as well. So this right side picture shows you the collapse of a road while underneath the road there has been an excavation, and this has been happened again and again, in particular in areas where we have asphalt roads or also sometimes concrete roads, which are placed on soft ground, in particular also on soft ground with the influence of groundwater. So this kind of monitoring is very important, and this type of collapse happens again and again. And I've been talking about in one of the previous virtual lectures about similar collapses for the Nichols Highway in Singapore, but also for projects in Germany, in China, in Shanghai, and also projects in South America, in Sao Paulo. Next slide, please. Next slide. Slide number 40. We are close to the end. So what are design constraints? Design constraints can result from conditions of shallow overburden, can result from conditions of existing nearby structures. Design constraint can also result from foreign objects in the ground. We have heard about bombs which have been placed during Second World War, and then they have been forgotten. And then 40, 50 years later, we are coming with some underground infrastructures and find foreign objects in the ground. We can also have design constraints from legal restrictions. We can have design constraints from auxiliary works, and we also have sometimes design constraints from the sensitivity and the high visibility of possible damages. So this project on the right side shows you the so-called Silvertown Tunnel in Australia. And it shows that the tunnel is connecting two stations, two metro stations on each side of the river. So lots of design constraints have been identified in this project. Next slide, please. Yes, this is a final lining, and we call it usually a summary. The final lining is also a summary. This shows two pictures. One is the metro line number 7 in Mexico City, actually. I have been a consultant for this metro section, line number 7, which had 10 stations, and out of the 10 stations, 9 have been all mine stations, and it's a typical conventional tunneling NATM project with excavation method developed in Germany in the early 80s and early 90s of the last century. And the right side picture shows the deep drainage for the interceptor, also in Mexico, with a cast in place final lining. So a typical project I've been working on both of them for quite a long time, and I'm very happy to see the success of this project. That the drainage tunnel, the deep drainage tunnel, is almost completed right now, and provides a huge improvement of the environmental conditions in Mexico City. Okay, thank you. I think this is the last slide, and I would just like to mention also whatever. Yeah, that's okay now also. Whatever questions may have been arisen during the presentation, I'm very prepared and glad if I can get these questions either right now, because we still have a little bit of time, I think, or if you want to write it down and keep it and send it to me through the Tunneling Association of India or CBIP. I will be happy to respond in writing also. So thank you. I appreciate to have this virtual lecture today. And I wish all those who could not attend today because of the COVID-19 virus, I would like to send well wishes and best wishes to Sunil Sharma and to everybody else who might have a chance to look into the presentation and might have also the one or the other question. And I will be happy to give you a competent response. So for now, I think if there are questions, we can enter into question and answer session.
Yeah, I think we still have about 15, 16 minutes to go.
Yes.
Or maybe we can take it even a little extra. So, ladies and gentlemen, should you have any question, you're most welcome to ask it now. You can even through a mail, send it to us, or write it to the professor directly. He will respond directly or through us, whichever way it is. But should you have a pressing question now, please shoot.
I hear a voice in the background, but I could not really understand.
We can't hear you. You have to speak louder and clearer. We can't hear.
So I have one question.
Can you speak into the microphone?
Is that Dr. Nathani?
Yeah.
Dr. Nathani, please speak into the microphone because something is wrong somewhere. Your voice is just at grade 2.
Now it is audible, sir?
Still not. I can hear a little bit, but then I don't know about Professor.
No, I could not. I can hear the voice, but I cannot understand the word.
Yeah. Okay, sir. Now it is audible, sir? It is audible?
Better.
Okay. So for this, one question for
Please.
the NATEM technology in the design, which classification will be the best? Whether we'll go for the Q or RMR or the RMI or other classification? Which classification will be the best classification for using the NATEM technology?
Yes, this is a very good question, because in every early design stage, this question, whatever the project is, comes up. And I can tell you that there is no, let's say, no all unique sole solution to answer this question. Sometimes we take Bieniawski, sometimes we take Barton, sometimes we take RQD or RMR, or sometimes even in the early stage of a project, you can go back to the Terzaghi classification and come up and make a more refining classification with RQD or RMR later on. So there are, I wouldn't call it that the Pope is the one who will give the right answer to this question, because the question is who is the Pope, But I can tell you, usually I do both Bieniawski and I do also Barton in both cases, and then come up with a comparison and then make the decision on what both of them will result.
And second, sir, one more thing for regarding numerical modeling. UDEC and 3DECs are used for the soft ground also. It will be enough for the soft ground also, UDEC and 3DEC modeling.
What I understood, it was not very clear to understand, but what I understood is your question is whether you should two-dimensional or three-dimensional modeling in soft ground and in hard rock, or was that the question?
Yes, correct only, sir. Correct only.
Okay. So I would think it depends on the capacity of your computer. If you can make three-dimensional analysis, I think it's better to go for a three-dimensional analysis. You will get better picture. But in the old days, we always did two-dimensional analysis also, and it was fine also. But nowadays, I think my recommendation would be go for a three-dimensional analysis and define the boundary conditions, the three-dimensional boundary conditions, or how far you go with the block of underground which you are investigating, and then make the three-dimensional analysis, whether it's soft ground or hard rock. But in hard rock, the analysis three-dimensional analysis usually is done if you have complicated structures, like the one we have seen, which is a future project from the CERN in Switzerland, on the Switzerland and France at the same time. So they are making all the three-dimensional analysis because the complexity of the intersections of shafts and tunnels and galleries and control rooms and all that, it is better to make it in a three-dimensional analysis, and usually computer capacities can bear it nowadays. So, but for actual, let's say if you have a long and deep tunnel, then you need, in addition to the three-dimensional analysis, you need to make the observation during construction. Monitoring and observation during construction is more important than computer analysis in the early stage. So have a good monitoring program and compare what has been in the geotechnical baseline report, what has been written for the rock mass and what is expected for the rock behavior. So that is something which you only can experience through on-site investigation and on-site observation.
Thank you very much, sir. Thank you.
My pleasure. Some more questions?
Okay, well, if there are no direct questions at this moment, I would still request the audience. Is somebody coming up? Somebody has a question? No. Okay.
Otherwise, write the question down and I will respond to it with pleasure.
Yeah, so please write it down, write through a mail, either to the Learning Association or else a direct question to the professor. He will be more than willing to respond. Okay,
Sure.
well, yeah, there's somebody speaking, you know, I can't really hear you. Please speak louder if you have a question or something. Anyone?
I can hear again the voice, but not the word.
There is, yeah. So we take it that it is an eddy current and not a.
Okay.
Okay. So, doctor, that leaves me with only, you know, winding up the. I think it was a very, very educative, very simplistically explained, explanation of the various nuances of the tunnels and the caverns and the systems, and what are the various issues involved which need to be addressed. Now, with that, I think we will once again thank you for being with us. We are a known person. In fact, we almost feel that we are connected to the University of Graz through you.
Thank you.
Getting educated every now and then. I'm sure this lecture series will continue. And very soon, once we are over the hill, maybe we'll again have an advantage of having you over to India and hearing you in person.
My big pleasure. Thank you very much. I'm very much eager.
And, well, I think I will request the audience to join me in thanking our guest speaker for the day for a beautiful talk.
Thank you. Thank you so much. Thank you very much.
Thank you, Dr. Wagner. God bless.
Thank you, Dr. Hayal. Thank you so much.
Thank you. It was.
We have mail ID of
Thank you everyone who joined in. Please bring in more people, bring in more colleagues who would take advantage. And thank you, Kalpana ji, for coordinating.
Thank you, sir. Thank you, sir.
Thank you.
Sir,
Thank you.
We have the mail ID of Professor, please.
I'm sending all the best wishes to Delhi and to India. And thank you for your attention. And I'm very confident that we will soon be behind the difficult times which we are going through right now. We are staying together, and I wish you all stay healthy and best wishes.
Thank you, sir. Thank you to all the participants. Thank you all for the lovely session.
Thank you, Miss Kalpana. Miss Kalpana.
Yes, sir.
It's correct pronunciation.
Absolutely correct.
Okay. Thank you.
Thank you, sir.
Okay. Best
Okay,
wishes.
bye-bye. Take
Bye
care.
bye. Bye bye. Thank you.
yes sir. Okay, मैंने आपको रेस्ट ऑफ द मिनट का मीटिंग मीट कर दिया सर. फाइन सर, मैंने देखा नहीं, एक्चुअली आज इवेंट था.